Hello students, welcome to this video lesson in ICT for Grade 8 series. In this lesson, you are going to learn how to draw flowcharts to solve simple problems using a sequence of instructions. Let us first look at the contents of the lesson. In this lesson, you are going to learn first what a sequence of instructions is. You will then see how to execute instructions in a sequence. We will also learn how to draw flowcharts using a sequence. Then we will have a quick test to check how well you understood the lesson. At the end of the lesson, we will have a recap to summarize what we learned. Let us start. What is a sequence? A sequence is the order in which we carry out the steps to solve a problem. Steps in a sequence are executed one after the other, from the first to the last. Most problems solved using a computer have three stages. The first stage is the input stage. In the input stage, we get the data needed to solve the problem. The second stage is the process stage. In the process stage, we are given instructions about what to do with the data. The third stage is the output stage. During the output stage, the result of the processing done previously is displayed. Let us now talk about order of operations in a sequence. Using sequence to solve a problem implies carrying out operations in the following order. Start with input, followed by process, and finally output. Let us see some examples of how a sequence of instructions can be used to solve problems. Our problem is to find the sum of two numbers. What are the steps to solve this problem? First, we must get the first number, then get the second number. We then add the first number to the second number to get the sum of the two numbers. Finally, we display the sum of the two numbers. We can easily recognize the three stages of computing in this sequence of instructions: input, process, and output. We will now learn how to convert a sequence of instructions into a flowchart. But before that, let us recall the symbols used to draw a flowchart. Flowchart symbols. An oval symbol represents start or end. It indicates where the flowchart starts or ends. A parallelogram represents input or output. Input is the point at which data is received, and output is the point at which results are shown. A rectangle or a box represents a process. It indicates some form of data manipulation. An arrow represents a flow line. It indicates the next instruction to execute. There is one more symbol, a symbol which we are not going to use in this lesson. It is a diamond shape. It represents a decision box. It indicates a place where we have to make a choice, hence allowing us to divert from the sequence. Decision symbols are not used in sequence flowcharts. We are now ready to convert a sequence of instructions into a flowchart. Let us start by listing our sequence of instructions to find the sum of two numbers. Get the first number, get the second number, add the first number to the second number to get sum of numbers. Finally, display the sum of two numbers. Let us now build our flowchart. Obviously, the first symbol will be the start symbol. Consider the instruction get first number. This is an input operation, a point at which data is received. Hence, we are going to use a parallelogram shape with the input first number written inside and add it to the flowchart. The next instruction, get second number, is also an input operation. We will again use a parallelogram shape with the instruction input second number written inside and add it to the flowchart. After the input stage comes the process stage. The instruction add first number to second number is an example of data manipulation, that is a process, which is represented in the flowchart using a rectangle. Let us add the rectangle to our flowchart with the instruction sum is equal to first number plus second number written inside. The last stage, output, is represented using a parallelogram with the information to display written inside it. Our problem is solved. We can end the flowchart. This is how our final flowchart looks like. We shall now see how we can modify a flowchart. We have a flowchart that accepts two numbers and output their sum. Modify the flowchart so that it will now accept three numbers and output their sum and average. The new instructions must not disturb the sequence input, process, output. Let us proceed. This is a flowchart we drew to input two numbers and output the sum of the two numbers. Remember, we need to find the sum of three numbers. We already have input the first and second numbers. We now need to get one more number. The instruction is input third number. The process of obtaining the sum will also change. We now have to get the sum of three numbers. Therefore, sum is equal to first number plus second number plus third number. Remember, this time we also have to output the average. Hence, we need a new process. We include a new process box and write the instruction average is equal to sum divided by 3. The first output remains the same, that is output the sum. We have a new result to display, the average. We add a new output box with the instruction output average and finally end the flowchart. Let us now work out a second example to consolidate what we learned about building sequence flowcharts. In this example, we will draw a flowchart to find the area and perimeter of a rectangle. Data we will need to solve the problem are the length and the width of the rectangle. These two will constitute the input stage. Calculations to be carried out are first the area and secondly the perimeter. These two will be done during the process stage. Finally, results to be displayed are area and perimeter. These form part of the output stage. Let us see how the flowchart to solve this problem will look like. As usual, we have the start symbol to begin the flowchart. In the input stage, get length becomes input length. Get width becomes input width. The next stage is the process stage. The first process is calculate area. In a process box, we write area is equal to length times width and add it to the flowchart. The second process, that is calculate perimeter. We write perimeter is equal to twice the length plus twice the width and add it to the flowchart. Finally, during the output stage, we will display area by writing output area in a output box and display perimeter by writing output perimeter in another output box. Our problem is solved, so we can end the flowchart. Our final flowchart will look like this. Those were examples that will help you to draw sequence flowcharts correctly. We will now have a test to check how well you understood the lesson. Read each question carefully and answer accordingly. We will start with some multiple choice questions. First question. A sequence of instructions is carried out A. in any order, B. one after the other, or C. starting from the last. We learned at the beginning of the lesson that steps in a sequence are executed one after the other, from the first to the last. Option B is the correct answer. Next question. During the first stage of a computing task, data is A. input, B. manipulated, or C. displayed. We learned about the three stages in a computing task, and the first stage was to get the data needed to solve a problem. Hence, data is input. The correct answer is option A. Next question. The last stage of a computing task is the stage A. calculation, B. process, or C. output. The three stages are input, followed by process, followed by output. The correct answer is C. output stage. We now proceed with some true-false type questions. When modifying a sequence flowchart, the input, process and output order can be changed. Is this statement true or false? We saw during the lesson that when we modify a flowchart, the sequence of input, process and output must not change. This means that the above statement is false. Next question. Decision symbols are not used in sequence flowcharts. Is this true or false? This is true. A decision box has two outgoing flow lines, allowing us to break a sequence by choosing the next instruction to execute. Now consider the following problem. A worker's salary is obtained by multiplying the number of days worked by the daily pay rate. A flowchart is used to solve this problem. The instructions used by the flowchart are given in the incorrect order. Input number of days, output salary, input pay rate, and start salary is equal to days worked times daily pay rate. Complete the flowchart by placing each instruction at the correct position. The completed flowchart will look like this. This question brings us to the end of the quick test. I'm sure you were able to answer all the questions correctly. It is time now to have a recap of what we learned today. We learned that a sequence means the order in which we carry out the steps to solve a problem, and that steps in a sequence are executed one after the other from the first to the last. A sequence to solve a problem implies three stages in the following order. First, input, followed by process, followed by output. Modifying a sequence should not disturb this order. With a recap, we come to the end of this lesson on designing flowcharts using sequence. I hope you enjoyed watching it. Until we meet for another video lesson, I wish you plenty of success in your studies. Goodbye.